Hello good day viewers. In this tutorial we are going to find a solution to this interesting radical equation. The question was posted by Garwa Isa yesterday on our Facebook group. Alright, let's get started. We have the square root of x squared plus 6x plus 9 then plus 1. The result is 0. How is that possible? I don't think it is possible because we expect this to be positive and we have another positive number, and the sum of two positive numbers will be a positive number greater than 0. Therefore, if at all there is a solution here, it must be an extraneous in the set of real numbers. But first of all, let us find a solution to it and test the result in the main equation to see whether we are going to get 0 to the other side. This is a perfect squared quadratic expression, but I don't want to factor it now because doing that will end up with one solution. But I know I can obtain two solutions. So let us take this one to the other side. You know, it is going to become negative. To the left hand side, we have the square root of x squared plus 6x plus 9. And to the other side, we have negative 1. And from here, we can square both sides. Squaring the left hand side, the square root will cancel the power of 2. Leaving x squared plus 6x plus 9, which I know is the same thing as x plus 3 whole squared. And this is equal to negative 1 squared is 1. And we can take square root again. Square root of the left hand side will be left with x plus 3. And square root of the other side will have plus or minus the square root of 1. And square root of 1 is 1. So we have x plus 3, which we can take 3 to the other side. It will become negative 3 plus or minus the square root of 1 is 1. So x could either be equal to negative 3 plus 1, which is going to give us negative 2, or negative 3, negative 1 is negative 4, negative 4. So we have two solutions. X could either be negative 2 or negative 4. But let us test in the main equation to see whether we are going to get 0 to the other side. Remember, we have the square root of x squared plus 6x plus 9, then plus 1. The result is 0. Let's start with negative 2. We have negative 2 squared plus 6 times negative 2 plus 9 under the square root, then plus 1. Is this equal to 0? That's what we want to find out. This is 4. This is negative 12. So we have 4 minus 12 plus 9. Then plus 1. Is this the same thing as 0? All right, let's find out. 4 minus 12 is negative 8. And negative 8 plus 9 is positive 1. So we have only 1 under the bracket, under the square root, sorry. 1 plus 1 equal to 0. And you know that square root of 1 is 1. And we have another 1 which is equal to 2. And 2 is not equal to 0. Hence, negative 2 will not satisfy. Now let us test for negative 4. So we have negative 4 in place of negative 2. We are going to test again. This is 16 minus, this is 24. Then plus 9 under the square root. Then plus 1. Is this the same thing as 0? 16 minus 24 is negative 8. And negative 8 plus 9 is 1. Square root of 1 is 1. Plus 1 is 2. And 2 is not equal to 0. So what is the actual value of x? That's what we need to find in the set of complex numbers. All right, let me pick the equation again. We have the square root of x squared plus 6x plus 9, then plus 1. The result is 0. I would like to take this to the other side. We have the square root of x squared plus 6x plus 9. The same thing, I don't want to factorize this first. I would like to take it to the other side first. Negative 1. So what can you remember about negative 1? Remember Euler's formula, we stated that e to the I pi plus 1 is equal to 0, which means that e to the I pi is equal to negative 1. So instead of this negative 1, we are going to replace it with e to the I pi. So let me do that. The left hand side will remain square root of x squared plus 6x plus 9. But the other side is now e to the I pi. So now we can square both sides in order to eliminate the square root to the left hand side. Square this and square this as well. The left hand side is just x squared plus 6x plus 9. And to the other side we have e to the 2I pi. And you know that this can be factorized, right? We have x plus 3 whole squared. And this is equal to e to the 2I pi. Remember that half of 6 is 3 and 3 squared is 9. This is why it is a perfect square quadratic expression. And if you expand this, you shall get this back. All right, then from here we can take square root of both sides. We have x plus 3 to the left. This is equal to plus or minus the square root of e to the 2I pi. You should know that this 2 right here will cancel this square root. We have x plus 3 to the left equal to plus or minus e to the I pi. Then we can take 3 to the other side. We have x to be equal to plus or minus e to the I pi minus 3. And hence this is the solution to this problem, which we can split as x either equal to plus e to the I pi minus 3 or x equal to negative e to the I pi minus 3. And hence we say that we have two solutions for this problem. But we can test it in the main equation. Our main equation is the square root of x squared plus 6x plus 9, then plus 1 outside. Will this be equal to 0 if x is either equal to this or this? Let's find out. Let's start with this one. Suppose x equal to e to the I pi minus 3. We have the square root of e to the I pi minus 3 as the value of x. Then plus 6 times the value of x again, which is e to the I pi minus 3. Then plus 9, all under the square root. Then plus 1, will that be equal to 0? This is squared, sorry. Let's expand it. Using binomial expansion, we take this, we square that. We have e to the 2I pi. Then minus 2 times this will give us 6 e to the I pi, 6 e to the I pi. Then negative 3 squared is 9. We have plus 9. Then you expand this, you have 6 e to the I pi. Then 6 times negative 3 is negative 18. Then plus 9, all under the square root. Then we have plus 1. Will this be equal to 0? By cancellation, you can see that this will cancel this because they have opposite signs. And 9 plus 9 is 18 minus 18 is 0. They will all go. All we have under the square root is the square root of e to the 2I pi. Then we have plus 1 outside. Is this the same thing as 0? This square root will cancel this 2. What do we have? We have only e to the I pi plus 1 equal to 0. But remember that e to the I pi is negative 1 plus 1. Is this equal to 0? Definitely 0 equal to 0. But let us check this one again, where we have negative e to the I pi minus 3. Our equation remains the square root of x squared plus 6x plus 9, then plus 1 equal to 0. This time around, we are going to substitute for negative e to the I pi minus 3 as the value of x. This is going to be squared. Then plus 6 multiplied by x again, which is negative e to the I pi minus 3. Then plus 9, all under the square root. Then plus 1. Is this the same thing as 0? If you expand this, you take this, you square that, you have positive e to the 2I pi. Then 2 times this will give us negative 2e to the I pi times negative 3 will give us positive 6e to the I pi. Then this squared will give us positive 9. Then you expand, you distribute this 6, you have negative 6e to the I pi. Then 6 times negative 3 is negative 18. Then we have plus 9, all under square root. Then plus 1. Is this equal to 0? We are moving. For cancellation, you can clearly see that this will cancel this. And 9 plus 9 is 18 minus 18 is 0. All we have is the square root of e to the 2I pi. Then plus 1. Is this equal to 0? Square root will cancel power of 2. We have e to the I pi plus 1 equal to 0. I remember that this is what? Negative 1. This is negative 1 plus 1, which is definitely 0. And hence the two solutions we have, since they satisfy the original equation, are e to the I pi minus 3 or negative e to the I pi minus 3. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.